Welcome back to Introduction on Microhydro. Many agencies further classify this into picohydro, nanohydro, etc. I am happy with the term micro. So excuse me if I don't use the term picohydro frequently here. Hydropower is one of the oldest and most widely used renewable energy which uses the natural flow of water to generate power. What is microhydro? Different countries have different definitions for microhydro. In India, even a 500 kilowatt hydro plant can be called micro, whereas in some other countries, micro is typically up to 200 kilowatt only. The power produced can be used for multiple applications. One of the most common applications is electricity generation because electricity can be easily transmitted over long distances and we have a lot of end-use equipment which can run on electricity. But microhydro does not mean only electricity generation. The direct mechanical power can also be used in driving other machinery like workshop tools, flour mills, oil mills, and lot of other agro processing machinery. Now, please click the link in the chat window and answer the question. You have about a minute. Yes, the right answer is mechanical power because that is what is produced by the turbine. If you want electrical energy, this mechanical power has to be converted in a generator. As you all know, whenever energy is converted from one form to another form, there is going to be a loss. So, definitely electrical energy produced will be less than the mechanical energy at the turbine. But looking at the previous picture, you may wonder where is the turbine? Yes, this is an interesting option where you can keep the turbine outside the powerhouse, keep the water out, take the power inside. You can see the turbine is mounted on a very long shaft. At one end is the turbine and in the other end is the pulley which can be connected to machines inside the powerhouse. This is one of the oldest types of turbines. You can see there is a conical wooden piece on which wooden blades are mounted, and you can also see the water coming through wooden chute. When the water hit the blades, the whole thing rotates. On the upper part, a stone is fixed and this grinds the wheat. This is a typical water mill in many of the Himalayan states in India. This is a water wheel used in Europe in the olden days. Do you notice any difference between the types? Yes, the one used in the Himalayan region is of vertical axis type, whereas the wheel used in Europe is of horizontal axis. Why is it so? Think about it. Now, let us look at different kinds of turbines which are commonly used in microhydro. This is the Pelton turbine, mounted directly on to an induction generator. It is known as a peltric unit. This is called a propeller turbine, which can be used in low heads. This particular turbine generates about 1 kilowatt at 1.5 meter drop. This one is called a firefly turbine. It is a tiny cross-flow turbine with a vehicle alternator fixed on top, which charges a battery. This one is called a turbo turbine, a variant of a Pelton turbine. Here you see a very interesting turbine. Can you see what it is? This is a normal centrifugal pump which is operated in reverse to act as a turbine. This kind of turbine is called pump as turbine, PAT, P-A-T. Now let us look at the advantages of microhydro. As we noted earlier, it is the cheapest of all renewable energy options. It does not consume the water. After the power is generated, the water is still available for other uses. The power is continuously available. It is a dispatchable source, meaning it can be readily connected to load demands, whereas solar and wind are not dispatchable because their output is not constant. Hydro is a very concentrated source of energy. For example, consider a 10 kilowatt power generation. Microhydro turbine needs about 10 square meter to generate the power. If you want to generate the same power with solar photovoltaic, you will need about 40 to 50 square meter. So that is what we mean when we say this is a concentrated source of energy. The energy available can be predicted. It can be predicted to some extent very accurately. It does not require any fuel. Water is the source, right? Water is the one which is used for generating power. It needs very little maintenance, so the running costs are typically very, very low when you compare it with diesel engines. As we have seen earlier, it has been developed, perfected over the last few decades. So systems can easily last for about 50 years without major additional investments. Technology is quite simple. It can be easily transferred and accessed in remote parts of the world. Of course, there is no free meal in the world. Microhydro also comes with some baggage. It is site specific. You cannot put a microhydro wherever you want. You need a naturally flowing water source, and that is not available everywhere. You can predict energy output only if you have enough data. So, reliable site data is very important. For a particular site, the maximum power which you can generate is limited. You cannot generate more than that. So the capacity expansion is not possible. Whereas if you consider a solar photovoltaic, you can simply add more panels, right? Seasonal variations like monsoon, summer affect the performance because the amount of water flowing through the stream will be varying. So it's important to know the seasonal variations. Now, let us touch base with the fundamental equation for a hydropower design. How does it work? Potential energy, a column of water standing in a pipe, is converted into kinetic energy when the water starts moving. Then this energy is transmitted to a turbine runner, which changes this kinetic energy into mechanical energy, and that is the power available at the shaft. The power equation is P is equal to 5 times Q times H. The answer you get is in watts when Q is the flow rate in liters per second, H is the height difference in meter, and the overall efficiency assumed is 50%. Very simple equation, isn't it? Let's see how we arrived at it. In this picture, you can see the various efficiencies of the different components. First, you have the civil works, where the water enters into the channel and goes to the forebay. The channel is about 95% efficient. Then the water enters into the pipe, the penstock, which is about 90% efficient. It then turns the turbine, where the kinetic energy is converted into mechanical energy. The turbine runs usually at about 80% efficiency. The turbine is then connected to a generator to generate electricity. The generator efficiency is usually about 85%. From the generator, depending on the distance, you will have a transformer. The transformer's efficiency is usually about 96%. Then you have the transmission cables, where you should have an efficiency of 90%. If you take all these efficiencies and multiply all of them together, you will get about 0.5, which is 50%. That is the overall efficiency. The scientific equation for calculating power is equal to rho Q G H and efficiency, where rho is the density of water, which is 1000 kilograms per cubic meter. Water flow rate is in cubic meter per second. The gravitational acceleration is 9.81 meter per second squared, and H is in meter. When we substitute the values, we get 1000 times Q times 9.81 times H into E. But remember, we use Q in liters per second. 1 liter per second is equal to 1 divided by 1000 cubic meter per second. So substituting that value in the equation gives you Q times 9.81 times H times 0.5. Approximating it, if you consider 9.81 as 10, it is 5QH. That is how we got the equation in the previous slide. So, when you go to the site, it is very easy to quickly calculate the power potential. Once you know the flow rate, the head, 5 times Q times H gives you the electrical power potential in watts. Okay, time for a couple of questions. Please click the link in the chat window and answer. Now, let us look at the answers. The first question is, which of the statements are true? The first statement is true. Micro hydro is the cheapest option. The second statement is also true, right? It can be predicted. Okay. But the third statement, it is false. It does not consume the water. Water is available even after the power is produced. So that statement is false. Technology is also very simple. It can be easily transferred. So the fourth statement is also false. Answer to the question 2 is about the power produced at the turbine. The answer is it is mechanical in nature. This can be converted into electrical energy by connecting it to a generator. Question 3 is the list of turbines. We have covered water mills, Pelton, cross-flow, turbo, propeller, and pump as turbine in this presentation. Answer for the fourth question is 5 times Q times H. 5 times 20 times 20 is 2000 watts electrical output. Question number 5, using the same equation, you find Q is about 30 liters per second.